Okay, guys, we are back here in our science. If you want to follow along, we are in our North Carolina coach book. We are on page 40, which is chapter 2, lesson 7 on physical and chemical changes. You are in your packet. You are on that backside there, and we are looking at physical and chemical changes when we're looking at this. What I'm going to do is I'm going to start off reading my closing reading so I know at least what I can look for in this aspect. A physical change is a change in which blank new materials form. Physical changes do not change the kind of blank an object is made of. Cutting a sheet of paper changes the size and blank, but not its properties. Most physical changes can be blank or undone. Matter can change from one state of another if you blank or cool it. So the very beginning is all about physical changes. So we're going to get started here in reading our material. And so when we're looking at this, zoom back out for you guys. When we're looking at this, we're going to start. You can mix vinegar and oil to make salad dressing. Mixing them together changes the way they taste, but they are still vinegar and oil. If you mix vinegar with baking soda, something different happens. New materials form. You learn about these two different kinds of changes in matter. Now, you guys know that baking soda and vinegar, when they do mix, that seems to be the most common science fair project when they want to create a volcano. So you do realize that there is a change happening. A physical change is a change in which no new material form. Physical changes do not change the kind of matter an object is made up. Suppose you cut a sheet of paper into pieces. You have changed the size and the shape, but it's still paper. So if I were to take this paper right here and I were to cut it or tear it, okay, it's still paper. Nothing is changing. I'm changing its size, I'm changing its shape, but I'm not changing its physical properties. When you cause a physical change in material, you change one or more physical properties. Recall that physical property is a feature that you can observe with your senses or measure with a tool. Most physical changes can be reversed or undone. After you fold a sheet of paper, you can unfold it. If you crumple it into a ball, you can then smooth it out again. You have learned that matter can change from one state of another if you heat or cool it. Ice is a solid state of matter. If you heat ice enough, it changes into a liquid. Heating it even more can cause the liquid to change into a gas called water vapor. The diagram below shows how water changes states. So ice cube, I heat it up, it becomes liquid. Liquid then becomes water vapor. So then I can also go, look how the arrows are going both directions. So if a water vapor cools, it's going to go to a liquid. It cools even more, it's going to become ice. So that's what happens in the winter time. If it rains and then all of a sudden it gets really cold at night, you might have an icy road. Well, because the liquid changed into an ice form. So let's see if we can answer any questions here. A physical change is a change in which blank new materials form. So a physical change is a change in which no new materials form. Physical changes do not change the kind of blank an object is made up of. So a physical change does not change the kind of, look at that second sentence right there. Physical changes do not change the kind of matter an object is made up of. So the answer here is matter an object is made up of. Cutting a sheet of paper changes the size and we just kind of checked about that one. If I'm going to cut it, it's going to change the size and the shape. But it's still paper. When you cause a blank change in a material, you change one or more of the physical properties. So when you cause a blank change in material, you change one or more of its physical properties. So right here, when you cause a physical change in a material, you change one or more of its physical properties. Recall the physical property is a feature that you can observe with your senses or measure with a tool. So when you cause a blank change, what kind of change is it? Physical. When you cause a physical change in material, you change one or more of its physical properties. Most physical changes can be blank or undone. Most physical properties can be blank or undone. It's right here in that second paragraph. Most physical changes can be, look at that second paragraph, reversed or undone. Matter can change from one state to another if you blank it or cool it. Well, what's the opposite of cool? Yep, if you heat it or cool it. Heat can cause water to change from an ice solid to a solid to if you heat it, becomes a liquid, or even a water vapor as a gas. A blank is a state in a physical change. A blank is a state in a physical change. Okay, so the diagram below shows how water changes state. What was the question again? The question said, a blank in state is a physical change. We'll come back to that one because that might be over here. A change in state is a physical change. Right there. Sorry, I'm losing my mind. It's right here. A change in state. I was looking for it. A change in state is a physical change. A change in state is a physical change. No blank materials form and change. So no, what kind of materials? No new materials form and the change can be blank. What's it going to be? It can be what? No new materials form. Change in state can be reversed. A blank is a matter made up of two or more materials. We have not gotten to. Okay, so we are going over to the second page, page 41 here. Okay, you can cause a physical change when you make a mixture. A mixture is made up of two or more materials. You combine different materials in a mixture, but no new materials form. A salad is a mixture of lettuce, tomatoes, onions, and other vegetables. They are mixed together, but the parts kept their own properties. The lettuce is still green and leafy. The tomatoes are still red. The onions are still small, like onions. But they all have the same properties they had when they were mixed together. Separating the parts of a mixture reverses the change. You can easily pick out different parts of the salad mixture. And when you have the same material, lettuce, tomatoes, onions, and other vegetables, you start with chemical. So let's look here. So a blank is matter made up of two or more materials. Up here, a blank is a material or a matter made up of two or more materials. Look at that first line. Okay, a mixture. So when I come down here, it's mixture. A mixture is matter made up of two or more materials. They are mixed blank, but keep their own blank. They are mixed. Look there, look after the word vegetables. They are mixed together, but they still keep their own. So they are mixed together. But the parts keep their own. What did we say they kept their own? Properties. They all have blank. They all have the blank properties they had. Blank, they were mixed. They all have the, look at Look at that last line before you see that heading that says what's chemical change. They all have the same materials that they started with, right? So they all have the same properties. They all have the same properties they had before they were mixed. Blank the parts of a mixture reverse the changes. Blank the parts of a mixture reverses the change. Okay, so let's look for that. Nope. Let's look at chemical change. We might be able to find it. After you cut a sheet of paper, the pieces are still paper. They are still made up of the same materials. But if you burn the paper, different materials form. Cutting paper is caused a physical change. Burning paper causes a chemical change. A chemical change is a change in which one or more new types of matter form. In a chemical change, materials react with each other. This means they combine in new ways to form other materials. The ability to react with other materials is called in a certain way is called a chemical property. You can observe a chemical property of material without changing it into something different. One chemical property is the ability to burn. When a material burns, it reacts quickly with oxygen in the air. Heat and light are given off. Wood, coal, gasoline, and natural gases are all materials that can burn. Iron does not burn, but it can rust. The ability of iron to form rust is a chemical property. So let's look to see if we can answer any of these questions here. Oop, wrong way. Okay, blank is the parts of a mixture reverses the change. Blank the parts of a mixture reverses the change. Okay, ready? It's in that second paragraph. Blank the parts of a mixture reverses the change. So what are we doing? Yep, separating the parts. The parts of a mixture reverses the change. After you blank a sheet of paper, the pieces are still the same. So after you, what do we do? What do we do? After you what a sheet of paper? What do we do? Cut. After you cut a sheet of paper, the properties are still going to the same. Cutting paper causes blank change. What do we say? What are we talking about right here? It causes what kind of change? A physical change. Burning paper causes a blank change. What do we say that burning paper is going to cause? What happens with burning paper? Can I reverse it? If I burn it, can I reverse it? No. So right here, burning paper is different. Cutting paper is a physical change. Burning paper causes a chemical change. A chemical change is the change in which one or more blank types of matter form. So a chemical change is a change in which one or more new types of matter form. So kind of types. New types of matter form. Materials blank with each other or combine in new ways to form other materials. Materials blank with each other. Materials what? You see it? Up there. Right there. Materials what? React. Oops, wrong way. React with one another, each other, or combine in new ways to form other materials. You cannot observe a chemical property of a material without blank it into something different. You cannot what? It's right there. You cannot observe it into something different. Oh wait, you cannot observe chemical properties of material without blank into something different. Sorry, not observe. I read that wrong. Oh, wrong way. Not observe without changing it into something different. One chemical property is the ability to blank. One chemical property is the ability to, look at that last paragraph. One chemical ability is the ability to burn. When a material burns, it reacts quickly with blank in the air. What does it react quickly with? Right here, second paragraph. Oxygen. Giving off the heat and blank. What is also be giving off? Giving the heat and the light. Wood, coal, gasoline, paper, and natural gases are all materials that can blank. They are all materials that can burn. Iron does not burn, but it can. What does iron do? It can't burn, but it can rust. The ability of iron to form rust is a chemical. What are we talking about? Change. Burning wood, fruit turning, blank tarnishing form a blank spoon. So we haven't gotten to that part. We have not talked about food. So I'm going to turn the page. We are now on page 42. The pictures below are some chemical changes that take place in a different materials react to oxygen. I'm sorry. When the log burns materials, the wood combine with oxygen in the air. They form ash, smoke, and gas of carbon dioxide. The apple core turns brown when it reacts with oxygen. Black tarnish forms on the surface of the silver spoon. The tarnish is a different material from silver. Orange rust forms on metal tricycle when it gets wet. Iron is the metal in the metal reacts with the oxygen in the air. Rust is not iron or oxygen. Rust is a new material. Signs of a chemical change. You can tell that a chemical change has taken place if you see new materials form. But that's not the only clue to a chemical change. A change of color is often a sign of chemical change. Vegetables and fruit change color when they often get ripe and also when they rot. Bananas turn from green to yellow to brown. Foods change colors when they are cooked. Egg whites go from clear to white when they are cooked. A cake gets brown as it bakes. Those changes of color are clues that cause chemical changes. Some chemical changes cause gases to be given off. If you add baking soda to vinegar, the liquid bubbles that gives off carbon dioxide. Also, the temperature goes down. If the temperature of a material changes without the material being heated or cooled, you can suspect that a chemical change has taken place. That's a big thing right there. If the temperature is changing and I'm not heating it and I'm not cooling it, you can almost bet that there's a chemical changing happening right there. Some of the things that happen in a chemical change can also happen in a physical change. Bubbles of a gas form in boiling water, but they do not mean that chemical change is taking place. One way whether a change is physical or chemical is to ask whether the change can easily be reversed. Most chemical change are much harder to reverse than a physical change. In fact, some chemical changes cannot be reversed. Okay, so let's look at our over here. Okay, it says, zoom out just a little bit more. Burning wood, fruit turning. What's the fruit going to turn, guys? What's the fruit going to turn? Up here, what's the fruit going to turn? I got to zoom out some more. What is the fruit doing there? Changing color. Tarnish forming on a blank spoon. Tarnish forming on a blank spoon. What kind of color? On a silver spoon. So tarnish forming on a, what kind of spoon was it? It wasn't a black spoon, it was a silver spoon. And blank rusting are all examples of chemical changing. And blank rusting, what kind is rusting? What kind of color is it? Not what color. What's rusting? The tarnish is a different color from orange. Rust forms on a metal tricycle. So what's the key? Rust forms on metal. So, and metal rusting are all examples of chemical changes. You can tell that a chemical change has taken place if you see blank materials form, if you can see what kind of materials. If you can see what kind of materials, look at that first thing right here. You can see new materials form or observe a change in blank. What else is happening? They are changing color. Some chemical changes cause blank to be given off. Some chemical changes cause blank to be given off. Some chemical changes cause gas to be given off. You're fine. You can keep going. If you add baking soda to, what was that favorite experiment? Baking soda to vinegar, right? Liquid bubbles are given off carbon dioxide. Also, the temperature does what? If I'm adding liquid to vinegar, the temperature is going to go down. If a temperature of a material changes, blank, the material can be heated or cooled. If a temperature of material changes, so if a temperature of a material changes without the material being heated or cooled, you can suspect that a chemical change has taken place. So, if a temperature of material changes without the material being heated or cooled, you can suspect that what are we talking about? A chemical change. Bubbles of gas form in blank water. Bubbles in gas form in blank water. Bubbles in gas form in boiling water. But they do not, does that mean a chemical change is taking place? One way to tell whether a chemical change is physical or chemical is to ask whether the chemical change can be it has to be easily reversed. Most chemical changes are much blank to reverse than physical changes. Most chemical changes are harder to reverse than physical changes. In fact, blank chemical changes blank can be reversed. Right here at the very end. In fact, some chemical changes cannot be reversed. So, in fact, blank chemical changes. So we're going to write some. On the very first one here, some chemical changes cannot be reversed. Data can be qualified or quantified. Blank data is a piece of information. So we haven't finished that. So now we're on this side over here. Qualitative data are pieces of information that can be described in words. Often, scientists use only their senses to gather quantitative data without using tools. Pieces of information described in numbers and units are called quantitative data. To gather quantitative data, you must count things or measure with a tool. For this activity, you will gather both kinds of data. You will need water, sugar, and a measuring cup and a spoon and a pan balance. Okay, so we're not going to actually do the experiment here, but qualitative data versus quantitative. Qualitative is often experienced in words. And when we look at things, are you giving a quality answer? Are you giving me all of the information? And a quantitative means you're giving me numbers of some sort. So when I look it down here, data can be qualitative or quantitative. Blank data can be used information to describe words. What did I say it was? It should be qualitative. To describe our pieces of information described in numbers and units is called numbers. Quantitative. To gather other quantitative data, you must count things or blank with a tool. You must count things or, right there, you must count them or measure with a tool. Okay, now we're going to go over and look at our questions 1, 2, 3, 4 in our chapter review. Okay, which sentence is true about physical change? A, physical change cannot be reversed. B, physical change causes new material to form. C, you can most often reverse a physical change. Or D, a change in state is not a physical change. Which sentence is true about physical change? If you don't remember, go back and look at your notes. Okay? Which one is a chemical change? A, shape in material. B, the ability of material to form rust. C, the texture of material surface. Or D, the state of matter of a material. Chemical property, if you go back and look at these notes that you just had, that first line when it says chemical changes, it's going to basically be able to give you a new information. Okay? 3, a chemical change takes place when A, water boils. B, an apple is cut. C, an ice cube melts. Or D, an apple rots. So chemical changes that are happening. Which question could be answered with a qualitative data? How tall the plant is. B, how do the plant flowers smell? C, how many leaves are on the plant? Or D, how much matter makes up the plant? You want qualitative, not quantitative, qualitative. So think about what qualitative means and what information will be received.